So we talked about y-axis integration and changing the subject of the formula and what we integrate with respect to cover an area between the curve and the y-axis rather than the x. What I'm going to do here is I'm going to set you a question on this. I want you to read the question, pause the video, have a crack at it, then come back and see the worked solution. Now there's only one question on this because it's not the biggest of topics that comes up in exams. However, it is still an important thing we know how to do and a vital thing that we can show all our working for and work through. Here you go. So I want you to calculate the shaded area there in that diagram of the curve y equals 4 over x squared, and I'm going to tell you it's between y equals 1 and y equals 4. So pause the video and have a crack. So how do we approach this? Well, like I said in the original video, what we want to do is we want to change our integral to the integral from a to b of f of y dy, function of in terms of y with respect to y. So to do this, we can read our limits off here. So there's our a and our b, but we have to be able to get a function of y, i.e. a function that is dependent on the y value. And in order to do that, we take our function here, where y is the subject, and we change it to x equals. So we want to take y equals 4 over x squared, fiddle about with it, and get x equals. Now to do that, first step should be to swap the x and the y. Because this is here, if I multiply both sides by x squared then divide by y, I can write it as x squared equals 4 over y. And then to get x on its own, I can just take the square root of the whole spiel. So x square root of 4 divided by y. That there is going to be the function that we integrate. So that there is my f of y. So equal to the square root of 4 over y. Put that into here, and then I can do my integration. So I've then got the integral from a to b of f of y dy. That's going to become the integral from 1 to 4 of the square root of 4 over y dy. First thing I need to do though is write this in the form that I can integrate. So something a times y to a power. Well, square root of 4 over y can be written as 4 over y to the half. Bring the y up and I can write that as 4y to the negative 1 all to the power of a half. And if I then take the half into the bracket, that gives me 4 to the power of a half. So square root of 4, which is 2. And then that becomes y to the negative a half. So I can change this and write it as the integral from 1 to 4 of 2y to the negative a half dy. So I've now got the function in an integratable form. I can jump in and do it. So same drill as the last time. 2y, raise the power by 1, so I get a half, and then divide by the new power of a half. And it's going to be between 1 and 4. Sort this out, so dividing by a half is the same as multiplying by 2. So that gives me 4, and then y to the half is the square root of y. And that's between 1 and 4. Now all I do is substitute the upper limit and lower limit in and see what I get. So what I then do is I get 4 times the square root of 4, take away 4 times the square root of 1. Square root of 4 is 2, 4 2's are equal to 8, square root of 1 is 1, times 4 is 4, I get 4 square units. Integrating with respect to y, as I said in the previous video, none of the general steps of integration change. The way we integrate doesn't change. We get it in this form here, a y to the n, and integrate it the same way we always have. Raise the power by 1 and divide by the new power. The only difference is instead of x to an n, it's a y. But that shouldn't make much of a difference really. And to get this, all we do is change the subject of the formula. Something we did at National 5 level mathematics. This should be fairly straightforward to get to a point like this where we can integrate. Then when we've integrated, sort it and make it look nice, and then do upper limit, take away the lower limit. That's what we did, and we got 4 square units for this one.